Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 13 video on the topic of sinking and floating from the chapter of physical quantities and measurements, where I will solve 5 multiple choice questions based on the concept of Archimedes principle that I discussed in part 12 video. So this video is part of the playlist ICSE Physics 8, where I discuss only the key concepts and formula related to numerical problem solving. If you find this video beneficial, then please like it, share it with your friends. And if you want to further support me, then kindly subscribe to my channel. And in that case, do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 13 video of solving 5 MCQs on Archimedes principle. Okay, so the first problem says that a body weighing WGF has an apparent weight of W by 4 GF when immersed in a liquid having density of rho L gram per centimeter cube. What fraction of the body is above the surface of the liquid if density of body is rho s gram per centimeter cube? Okay, so we have to find the fraction of the body above the surface of the liquid. Okay, so the scenario is something like this. So we are having this is the liquid. Let's say this is the body immersed in the liquid. So okay, let's say a body weighing WGF. So weight of the body is WGF, which means that the mass of the body is W gram. Okay, has an apparent weight of W by 4 GF. So we know that when a body is immersed in a liquid, two forces act. Two forces act on the body. One is its own weight, which will be WGF, and another is the weight that is acting vertically upwards on the body, that is the buoyant force FB. We also know that the apparent weight is W dash is equal to the original weight in the air, that is W, minus the buoyant force. Okay, now buoyant force is based on the value of the buoyant force will be the weight of the liquid displaced. That is, and that liquid will have a volume which is equal to the volume of the body which is below the surface of the liquid. So let's say the whole volume. Let's say the whole volume of the body is V ml, V centimeter cube. Since all the units are given in gram in CGS, let's say the volume of the body is V centimeter cube, and let's say V dash centimeter cube is the volume of the immersed part of the body in the liquid. So we know that the buoyant force is equal to the weight of the liquid displaced, and what is the weight which depends on the mass of the liquid displaced, and which again depends on V dash. That is, the liquid displaced will have a volume equal to the volume of the immersed part of the body, which we have considered to be V dash centimeter cube. So the buoyant force will be the mass of the displaced liquid, which is V dash, volume is V dash, and the density of the liquid is rho L. This multiplied by the acceleration due to gravity G, this much ground force. This much ground force is FB. Okay. Now, what fraction of the body is above the surface of the liquid? If, okay, above the surface of the liquid, if density of body is this. Okay, it also says that the apparent weight is given. the apparent weight, which is W dash, is given to be W by 4. W by 4 GF is equal to uh, WGF. The weight of the body is WGF minus FB is V dash rho L. This multiplied by G. This G is the gravitational acceleration due to gravity, which is 9.8 meter per second square, and this much GF. If I ignore the units on the both sides, I get W by 4 is equal to W minus V dash rho L. V dash rho L. Okay. Also, we know that since we have considered the total volume of the body to be V centimeter cube, we know that the mass of the body is W gram. So W should be equal to V multiplied by the volume of the body multiplied by its density, which is rho S. This much gram. Weight W is equal to V rho S. Okay. So this implies we have W by 4 is equal to W minus V dash rho L. If I substitute W as V rho S, I have V rho S by 4 is equal to V rho S minus V dash rho L. Okay. This implies that if I need to find the V dash. The question has asked what fraction of the body is above the surface of the liquid. What fraction of the body is above the surface of the liquid? We have considered V dash to be the volume of the liquid immersed. That is the volume of the body which is immersed inside the liquid. Okay. So basically, what is the volume of the body which is above the surface of the liquid? It will be V minus V dash, and the fraction will be V minus V dash by V. This we have to find. Let's see. Okay. This we have to find. Okay, from here we have if we simplify this equation, if I express V dash in terms of V, I will get V dash rho L is equal to V rho S minus rho S by 4, which is equal to 3 by 4 V rho S, 3 by 4 V rho S. Okay, so this implies V dash is equal to 3 by 4 V rho S divided by rho L. Okay, now what will be this fraction? This is the fraction that we have to find. Okay, so we have V minus V dash is 3 by 4 V rho S by rho L, and this whole divided by V. This will be, if I take V common from the numerator, I get V 1 minus 3 by 4 rho S by rho L whole divided by V. So V cancels out. This becomes 1 minus 3 by 4 rho S by rho L divided by 1. Okay. This, after further simplification, if I simplify the numerator, I get 4 rho L minus 3 rho S divided by 4 rho L. So this should be the fraction of the part of the body which is above the surface of the liquid. So the correct choice is rho L, 4 rho L minus 3 rho S. My answer is matching with is close to A, but in the choice A it is given as 3 rho S minus 4 rho L. Uh, mm, Let me check if I did the problem correctly or not. So the problem has asked what fraction of the body is above the surface of the liquid. So the volume of the liquid above the surface of the volume of the body above the surface of the liquid is definitely V minus V dash, and its fraction to the whole part of the body is V minus V dash by V. Okay. Now what we are getting, let's see if I correctly expressed V dash in terms of V and rho S. So the apparent weight is given to be W by 4 GF. So we have W by 4 GF is equal to WGF minus FB. FB is V dash rho L. Okay. So we have W by 4 is equal to W minus V dash rho L. V dash rho L. Okay. So this means this implies that what is W by 4? What is W? W is the mass of the body. W is the mass of the body. Since its weight is given to be WGF, its mass is W. So W will be equal to V into rho S. Okay. So we have V rho S divided by 4 is equal to W, that is V rho S minus V dash rho L. So we have V dash rho L is equal to V into rho S minus V multiplied by rho S minus rho S by 4, which is 3 by 4 V into rho S, which implies that V dash is equal to 3 by 4 V into rho S by rho L. Okay. So we have this V dash in terms of V. Okay. Now the fraction will be V minus V dash by V. Okay. So V minus V dash is 3 by 4 V rho S by rho L by V, which is equal to, if I take V common in the numerator, we get V into 1 minus 3 by 4 rho S by rho L and whole divided by V. So this becomes VV cancels out. We have 1 minus 3 by 4 rho S by rho L, 1 minus 3 by 4 rho S by rho L, which is equal to 4 rho L minus 3 rho S divided by 4 rho L. So I think I have incorrectly given the choices. I have incorrectly given the choices. The fraction as I have calculated is coming out to be this one. Now if you think I have done any kind of silly mistake or calculation mistake or applied the concept incorrectly, then please feel free to let me know in the comment section. The main objective is to see how I am applying whether we are applying the concept correctly or not. Okay, let's see the next problem. Question number 2. A solid and a liquid has a density of rho gram per centimeter cube and 3 rho gram per centimeter cube respectively. What volume of the body is immersed in the liquid if apparently the body becomes weightless and has a volume of VmL? So what volume of the body is immersed in the liquid? Okay, so let's say this is the body. The density of the body is given as rho gram per centimeter cube. Okay, and the volume is also given as VmL. The volume of the body is given as VmL. So the mass of the body will be V rho this much gram. Let's say what volume of the body is immersed in the liquid. Let's say V dash with the volume V dash ml with the volume of the immersed part of the body in the liquid. Now, since it is given that what volume of the body is immersed in the liquid if apparently the body becomes weightless, which means that the apparent weight is apparently the body becomes weightless means W dash the apparent weight is 0. This implies we will have from the fact that apparent weight is equal to original weight in air minus the buoyant force. So we will have W equals to the buoyant force. In this situation, the buoyant force will be equal to W, which is the weight of the body. This implies that what is the weight of the body? Its mass multiplied by G. This G is the explosion due to gravity. This much we can say will be gram force. Mass of the body is V rho gram. So the weight of the body will be V rho gram force. This should be equal to what is Fb, the buoyant force. The buoyant force is the mass of the displaced liquid, and this displaced liquid has a volume of V dash. So since the density of the liquid is given as 3 rho, we can say that the mass, the buoyant force will be equal to the mass of the displaced liquid which is having a volume of V dash, so V dash and 3 rho, this much gram force. So I can ignore the unit from both sides, and I have V rho is equal to 3 V dash rho. So this implies that V dash is equal to V rho divided by 3 rho. This is equal to rho cancels out. This is equal to V by 3. So the volume of the immersed part of the body is V by 3 ml. Hence the correct choice is B. B is the correct choice. Okay, let's see the next problem. Question number 3. A body of weight WGF floats in a liquid of density rho 1 gram per centimeter cube with V1 ml of volume of its immersed part. The body floats in another liquid of density rho 2 gram per centimeter cube with V2 ml of volume of its immersed part. If rho 1 is to rho 2 is 1 is to m, then the value of the ratio V1 is to V2 is. So we are having two experiments are done with two liquids. Let's say this is the liquid having density rho 1 and the body is immersed. And so the volume of the body immersed inside the liquid is given to be V1 ml. Since the weight of the body is given as WGF, I can say the mass of the body is W gram. Okay. Now, also it is given that a body of weight WGF floats. A body floats in a liquid only when its apparent weight is 0. That is, its weight is equal to the buoyant force. Body floats implies W dash is 0. It is floating because no net force is acting on the body either downwards or vertically upwards, which means that W has to be equal to Fb. So this implies W has to be equal to Fb, where Fb is we are considering the buoyant force in the first case, that is for the liquid of density rho 1. Also for liquid we are having for liquid density rho 2, let's say we are having the body is immersed, and this part that is the volume of the immersed part of of the body is given to be V2 ml. The mass is same, mg, m gram, w gram, mass is w gram, and here also since it is floating in the liquid rho 2 having density rho 2, the weight, the apparent weight will be equal to 0. That is the its own weight will be equal to the buoyant force. Now what will be the buoyant force, that is Fb, in the first case? So we will have, now what is W? W, what is W? Okay, so we have W is equal to, what will be Fb, the buoyant force in the first case, that is when the body was floating in liquid of density rho 1. It will be the mass of the displaced liquid, and that displaced liquid is having a volume of V1 ml. Since it is given, the volume of the immersed part of the body is V1 ml. So we will have the volume of the displaced liquid will be V1 ml. So we must have W is equal to V1. The mass of the displaced liquid will be V1 rho 1. Okay. So the buoyant force is actually V1 rho 1 GF. Okay. So we have W is equal to V1 rho 1. Now for the second case, that is when the body is floating in the liquid of density rho 2, also we will have apparent force is equal to 0. This will imply that the weight of the body should be equal to the buoyant force. Let's say the buoyant force in the second case, that is when the body is immersed in the second liquid, be Fb dash. Now what will be Fb dash? Fb dash will be the weight of the displaced liquid, and that displaced liquid is having a volume of V2 ml. So its mass will be V2 rho 2. So we will have W equals to V2 rho 2. Now we have W is equal to V1 rho 1 and also W is equal to V2 rho 2. So we can say that V1 rho 1 should be equal to V2 rho 2. So this implies V1 by V2 is equal to rho 2 by rho 1. Now the ratio of rho 1, it is given that rho 1 is to rho 2 is equal to 1 is to m. So this implies that rho 1 by rho 2 is equal to 1 by m. This implies rho 2 by rho 1 is equal to m. So we have V1 by V2 is equal to rho 2 by rho 1 is equal to m. So this implies that V1 is to V2 is equal to m is to 1. So the correct choice is choice B. Let's see the next problem. Question number 4. A solid body having a density of rho 1 gram per centimeter cube when immersed in a liquid of density rho 2 gram per centimeter cube has an apparent weight of capital P GF. A solid body having a density of rho 1 gram per centimeter cube when immersed in a liquid of density rho 2 gram per centimeter cube has an apparent weight of P GF. So we know the apparent weight W dash is equal to the weight of the body in air minus the buoyant force. Okay. So the apparent weight is given as P GF. So this implies P, this is ground force, is equal to W. We don't know the W. Let's say the volume. Let's say the volume of the body be, let volume of let volume of a body be V centimeter cube. So we will have the mass of the body will be V rho 1 this much gram. So this implies the weight of the body should be mg. This g is the acceleration due to gravity, or we can say the weight will be mgf m gram force, which is equal to v rho 1 gram force. Okay. So in the equation, W dash is equal to W minus FB, where FB is the buoyant force acting on the body, W is the weight of the body in the air, and W dash is the apparent weight of the body when it is immersed in the liquid. W we have is V rho 1, and what will be FB, the buoyant force? It is given that if 2/3 of the body is inside the liquid, 2/3 of the body is inside the liquid, that is, the volume of the body which is immersed in the liquid is 2/3 of the original volume. So the volume of the so we can say the volume of the displaced liquid will be V 2 by 3 V. 2 by 3 V is the volume of the liquid displaced, multiplied by its density will give the mass. So we have this. The question has asked the mass of the body is, okay, so this is equal to V rho 1 minus twice V rho 2 divided by 3. This is equal to, if I take V common, V rho 1 minus twice rho 2 by 3. This is equal to V into thrice rho 1 minus twice rho 2 divided by 3. From here we can get the volume of the body. V is equal to will be P by 3 rho 1 minus 2 rho 2 divided by 3, which is equal to thrice P divided by 3 rho 1 minus twice rho 2. This is the volume of the body. So the mass of the mass of the body then will be the volume of the body divided by its density rho 1. This is equal to 3 P rho 1 divided by 3 rho 1 minus twice rho 2. This much gram will be the mass of the body. So the correct choice is choice D. D is the correct choice. Okay, let's see the last problem, question number 5. A body of density rho gram per centimeter cube is immersed in a liquid of density 3 by 2 rho gram per centimeter cube, so that 2/3 of the body is below the liquid surface. At this point, the body will tend to move up towards the liquid surface, move down towards the bottom of the liquid, stay still, or cannot be determined. Now, when a body is partially or wholly immersed in a liquid, it is we know that when a body is partially or fully immersed in a liquid, then two forces are acting. One is the weight, its weight, and other one is the weight which is acting vertically downwards, which will try to sink the body in the liquid, and another force is the buoyant force which is acting vertically upwards on the body, which will try to push the body up towards the surface of the liquid. Now, at any in any situation, whether the body will tend to move down, that is, the body will tend to move towards the bottom of the liquid, or it will stay still, or it will tend to move up, will depend on the relative values of W and B. So we have to compare FB and W and see which is greater. If FB is greater, then the net force will be upwards, and then the body will tend to move up. If W is more, then the net force W minus F, the net force will be downwards. So the body will tend to move down. And if W is equal to FB, that is, then there is net force is zero, the body will not move, it will stay still, which is the case of floating. Okay. Now, okay, so it is given that, let's say the volume of the body is V centimeter cube. Okay, so the mass, sorry, the mass of the body is its volume, its density, V rho, this much gram is the mass. So this implies that the weight of the body in the air is V rho, this much gram force. Okay. Now it is given that, now what will be the buoyant force? What will be the buoyant force? The buoyant force will be the mass of the displaced liquid, the weight of the displaced liquid. How do we find the weight of the displaced liquid? We need to find its mass. Now we know the density of the liquid. To find its mass, this mass of the displaced liquid, we need to know its volume. It is given that 2/3 of the body is below the liquid surface, which means that the displaced volume of the displaced liquid is equal to the volume of the body immersed in the liquid, which is 2/3 of the volume of the body. So the volume of the displaced liquid is 2/3 into V. This when multiplied by the density of the liquid, which is 3/2 rho, will give the mass of the displaced liquid. So the buoyant force FB will be this much gram force. Now what is FB? FB we can see is V rho gram force. Also we saw that the W is equal to V rho GF. So this implies that W is equal to FB. So this implies we can see that the buoyant force is equal to the W, that is the weight of the body in air. This implies that W dash, which is W minus FB, is equal to 0. This implies that body is floating. Body is floating in this situation. This implies that body will stay still, that is, it will not move. When a body floats, means it is not moving. It is either not moving down or it is not moving up. Hence the correct choice is C. If in this problem, if the buoyant force is less than W, this will imply that the net force is W minus FB. This will be since if W is if the buoyant force is less than the W, then definitely the net force will be downwards, and that net force will be W minus FB. This will imply that W dash will be 0, greater than 0, which means that since the apparent weight is greater than 0, that apparent weight will tend to sink the body further towards the bottom of the liquid. And if FB is greater than W, this implies that so this implies that 0, if I subtract in this inequality, if I subtract both sides with FB, I get I get FB minus, in an inequality, I hope you know, in an equality, in this case it is greater than, FB greater than W, in an inequality you can subtract or add any non-zero value, constant, the inequality remains same. So I can say FB minus FB greater than W minus FB. This implies that FB minus FB is 0 greater than W minus FB is W dash. This implies, or we can say W dash is less than 0, which means that what is the apparent weight? By weight, we always mean that a force that is acting on the body vertically downwards. Now, since in this case the weight we are having as negative, it means that there is a net force of acting upwards on the body. So, in this case, for the case when FP is greater than W, the body will tend to move up. Because FP is greater than W, it will the net force acting on the body is vertically upwards, so which will tend to move the body towards the surface of the liquid. So with this, it comes to an end in solving 5 multiple choice questions based on the Archimedes principle, that is the apparent weight of a body when it is immersed in a liquid based on the densities, which I discussed in the previous part video, that is part 12 video. I hope that solving this problem will give you a good clarity about the Archimedes principle. Once again, if this video was beneficial, please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I don't think I will be able to make more questions on this Archimedes principle, so probably I will start discussing about whether a solid body will float or sink in a liquid when their densities are given. Based on the density of a solid and the density of a liquid, whether a solid will sink or float, and how it will float, all these cases and conditions I will discuss separately in each video. That is, in one video I will discuss the situation when the density of the solid is less than the density of the liquid. In another video I will discuss when the density of the solid is equal to the density of the liquid, and in another video I will discuss when the density of the solid is greater than the density of the liquid, and we will see what happens. So please stay tuned for those videos to come soon. Thanks for watching, and until the next video, take care and bye.